What about option 2? We should still get that approximation of 5.600. Now we're going to have to be really creative here. What do I mean by being really creative here? We've got a variable in both exponents. The other approach, what was perhaps most difficult about it, was having to deal with that x plus 5 and then distributing the natural log of 3 to that. Started to make things look really messy. How about we take the log in base 3 of both sides instead, on the left-hand side. It's better than the power rule here. We're just going to get cancellation, and x plus 5 is all we're left with at a regular level. On the right-hand side, we do have to apply the power rule. And the calculator can't work with base 3. You're going to have to do change your base at some points. Well, if I get the like terms together, by subtracting x from both sides and factor that x out, remember, when you factor an x out of itself, you're going to have 1. Then divide both sides by this. The thing multiplied to x. Change your base. Log of 8 in base 3 will be the natural log of 8, and then the natural log of the old base in the base of the denominator. The in the denominator of the fraction. Now, if in a later class you're taking another math class and you're continuing to deal with logarithms, the teacher is likely to not accept a fraction inside of a fraction. If you're careful using parentheses, you can do the calculation, but sometimes they want to see that exact answer. So I can multiply top and bottom by natural log of 3, because that's the denominator of my mini fraction, as Dr. Evil would say, from the Austin powers. That would cancel on the first one, but we're also having to distribute to the second one. And if I remember right, that's what we had before. Let's see. 5 times the natural log of 3 divided by natural log of, let's see if I can, yep, divided by the natural log of 8 minus the natural log of 3. So we're still going to get that 5.600, just like we did before. Hopefully you find this approach a little bit easier, but at least you've got two options, and I could think of at least one more. It's probably more than I'm thinking of. What we're going to be dealing with next are equations that have variables in the logarithm.